Okay, so this is the 2023 Higher Level Applied Maths paper question 8. Two balls P and Q are projected into the air from points A and B, which are a distance d apart along the horizontal y-axis. The motion of the balls may be modelled as projectile motion in a vertical plane, ignoring the effects of air resistance. P is projected from point A at time t is equal to 0 with initial velocity 38 meters per second at 41 degrees to AB. Q is projected from point B at time t is equal to 1 second with initial velocity u meters per second at 64 degrees to BA. P and Q collide in midair when t is equal to 3 seconds. Show that u is equal to 28 meters per second to the nearest whole number. Okay, so what we're going to do is just look at the initial velocities of both of the spheres. So if we look at P first, so we take P. The initial velocity of P is going to be 38 cos 41 degrees in the I direction, because remember the velocity is in this direction here. It's 38 meters per second. So if you were to just decompose that, this is 38 cos 41 degrees. And this is 38 sine 41 degrees. So in the I direction we're looking at 38 cos 41 degrees plus then 38 sine 41 degrees in the J direction. Okay, so Q then is in the opposite direction. So the initial velocity of Q is going to be, we don't know the speed, the initial speed, so it's just u. So it's going to be minus u, again for the same reasons, cos 64 degrees in the I direction plus u sine 64 degrees in the J direction. Okay, so what we're going to do in order to show the initial velocity is 28 meters per second, we're going to have a look at the two spheres when they collide. Now when they both collide, they've both traveled the same distance in the y direction, in the J direction in other words. So we're going to calculate the distance that P and Q travel in the J direction when they collide, and we're going to equate those two distances. So in order to do that, we're going to use S is equal to ut plus half a t squared. For in the J direction only, we're going to just look at the J direction only. Or the Y direction. So for P then we need the initial velocity in the J direction, which is 38 sine 41 in the J direction. And then that's u, so we've got to multiply that by t. Well, it takes 3 seconds for P to reach the collision point, plus half at squared. So it's going to be minus half of 9.8, and then t squared, which is 3 3's 9. That has to be equal to the distance that Q has travelled at the point of impact in the J direction. So again, that's ut plus half at squared. So the initial velocity is u sine 64 degrees times the time it takes for Q to reach the point of impact. And we're told in the question that Q is projected from a point B at time t is equal to 1 second. So it starts a second later than P. So the time it's going to take to impact is going to be 2 seconds. And again, it's minus half 9.8 times 2 squared, which is 4. So all we've got to do here really is just isolate u. So if you do everything on the left-hand side, what you get is 30.6907293. And on the right hand side you'll get u times, if you do this on your calculator, you get 1.797588093. And then this part here on your calculator you'll get 19.6. So it's just simple algebra after that. Bring over the minus 19.6, divide by 1.797 and so on, and you get an initial velocity then of 27.9767815, and that's meters per second. And it says here to the nearest whole number, so that means u then is just going to be equal to 28 meters per second. That's really it for part 1. Let's have a look at part 2. Calculate d. So in this case, what we want to do is calculate the distances in the I direction for both spheres. So what we're going to do here is we're going to use s is equal to ut plus half at squared as well, and as our initial velocity, since we're looking at the distance in the I direction, we want this distance here, we're going to use this part of our vectors here, the I parts. So let's do all of that. We're only looking at the I direction now, and we're going to look at s is equal to ut plus half at squared. Now, because we're looking at the spheres traveling in the I direction, there's going to be no acceleration due to gravity that we need to take into account. So this part here will just be 0. So really we're just looking at s is equal to ut. So what we're going to do is we're going to add the two distances that both the spheres travel, and that'll give us our d, if you like. So d is going to be equal to the distance that p travels. Our initial velocity is just ut, so we're just going to be looking at u, which is 38 cos 41. So it's 38 cos 41 degrees multiplied by t. Well, it takes 3 seconds. Then we're going to look at q. Well, the initial velocity for q in the I direction is minus u cos 64. Now that'll give us a negative distance. We can't use a negative distance. Really, we want the positive version, the absolute value of this. So I'm going to use u cos 64 here. So it is 28. We worked out that u is 28 in the previous question. So it's cos 64. And q is traveling for 2 seconds before impact. So you just need to do all of that on your calculator, and you get 110.58566764 meters. Just says calculate d. Again, it doesn't give us any indication as to how many decimal places it wants, but that's what my calculator gave me anyway. Okay, so let's look at part 3 then. Part 3. In terms of I and j, calculate the velocity of p and the velocity of q when the balls collide, I when t is equal to 3. Okay, so what we're going to do in this case is we're going to use v is equal to u plus at. Now we want the velocities at the point of impact, and what we know is that the velocity in the j direction will change, the velocity in the I direction will not change. So we already have the velocity in the I direction in both cases. So what we need to do is work out the velocity in the j direction for p and q. So let's look at p first. We have the velocity in the j direction then, in the y direction, is going to be equal to u for p is 38 sine 41. That's our initial velocity in the j direction, 38 sine 41. Plus at was going to be minus 9.8 times the time, which is 3 seconds. Now when you work that out, you will get a velocity of minus 4.4697566898. Again, I don't think you need that many decimal places, but that's what my calculator is giving me anyway. So therefore, the velocity then of p at the point of impact is going to be, you can work this part here out on your calculators, and that will give you 28.67896405 in the I direction, and then in the j direction we've just worked that out, it's going to be minus 4.4697566898 in the j direction. Again, I don't think they're going to require that many decimal places, but let's move on to Q. So Q then, same thing again. We want the velocity in the j direction. Velocity in the j direction here is going to be u plus at. The initial velocity for Q is 28 sine 64. 28, we've worked out this is 28 sine 64. 28 sine 64 degrees. And again, it's minus 9.8, and it was traveling for 2 seconds. So when you work that out, you'll get 5.5662333296. So that means then the velocity of Q at the point of impact is going to be, again, you've got to work out the I vector, so that's minus 12.27439.211 in the I direction, and then plus 5.5662333296 in the j direction. Again, as I say, you don't need that many decimal places, I'm sure. Okay, so that's it. We've answered the question. We have the velocity of P and the velocity of Q at the point of impact after 3 seconds. Okay, next one then. Calculate the dot product Vp and Vq when t is equal to 3. Okay, so the dot product then is just going to be what you get when you take these two vectors and carry out the dot product. Multiply the I coefficients there and the j coefficients if you like. So let's do that. So these are our two vectors, so what we've got to do is the velocity of P dot the velocity of Q. So all you've got to do here is multiply these two numbers here, these two numbers here, and add them. So when you do that, your answer is minus 376.8965597. And that's really it for part 4. Let's have a look at part 5. Hence or otherwise calculate the acute angle between VP and VQ when t is equal to 3. So the acute angle. So we have a formula for doing that. It's in the tables. It's cos theta is equal to the dot product, which we've just done, of P and Q, divided by the modulus here of Vp times the modulus of Vq. So when you do that, I mean, it's just going to be the answer that we got up above, which was minus 376.8965597 divided by the square root of these numbers here. I'm not going to put in all the numbers. I'll just put in 2 or 3 decimal places. So let's say 28.68 squared plus minus 4.47 squared. Then you got to multiply that by the square root of, same thing again, these two here, which we've got to square. So it's minus 12.27 squared plus 5.57 squared. Now I've worked all of that out using all the digits. Now I don't have all the digits here, but I worked it out using all the digits, and what I ended up with was cos of theta is equal to minus 0.9635824.229. So again, I haven't put all the decimal places in up here, but this is what you get if you do. So all you got to do is cos inverse then. So you do cos inverse of minus 0.9635 and so on. That'll give you a theta, a final theta of 164.4897057. But if you read the question, it says hence or otherwise calculate the acute angle. So this is the obtuse angle. So this is obtuse. We want the acute angle, so theta is equal to 15.5102943 degrees, and this is the acute angle. So this is the angle they were actually asking for. So again, too many decimal places probably there, but that's the procedure anyway. Okay, and that's it for this question.